Hey guys, this is Roshni from LearnoHub, the free learning platform where you get to learn for free. And the website is learnohub.com. So in this video is obviously in continuation with the previous video, and in this video we are going to learn about mean, median and mode. That's the agenda. Are you all ready? Get set, go!
Now we introduce another concept of mode. Now, till now we have learned about arithmetic mean or mean. Now, calculating mean is not enough in all the cases. Now, we might encounter scenarios where calculating mean doesn't help us. So, let us take an example of such a scenario. Let us say that this shopkeeper, he observes that the sale for different items in his stationery shop for a particular year was this. That is, in the last year or in this year, the number of books that he sold was maybe 750. Pens was 45,000, pencils 50,000. So he actually sold 50,000 pencils from his shop. Glitter pens 30, glue 610, chart paper 71, and so on. So this is a list which tells how much was the sale for each of the items in his stationery shop. Now, just to keep things simple, let us now assume that his profit margin is more or less same for all these different items. Now, looking at this data, how should he approach to buy things for his shop for the next year? How should he manage his inventory so that he is in profit the next year? So what would be a wise decision for the shopkeeper to do? Now, see, there could be many different approaches. So let us say that he could have approach 1. So his approach 1 could be, let us find the mean of this data. So finding mean of this data. So if you find the mean would be something like this: 750 plus 45,000 plus 50,000 plus 30 plus 610 plus 71 divided by how many items? 1, 2, 3, 4, 5, 6. So divided by 6. So this value comes out to be 16,076. So this is the approximate value that he gets. So what does this mean? This means that if we assume that all the items were sold in equal numbers, then each item sold were 16,076. So if we assume that everything was sold equally, so in that case we can say that 16,076 glitter pens were sold, 16,076 pencils were sold, 16,076 glue were sold, and so on. So therefore, one option is that for the next year, he purchases 16,076 number of all the items. Right? So he has calculated the mean from this data, and then in the next year, he plans that, okay, so this year let me do one thing, let me purchase all these items for my shop. To build the inventory in the shop. So let me purchase all the items, but this time I will purchase everything these many numbers. So I will purchase 16,076 books, I will purchase 16,076 pens, pencils, glitter pens, glue, chart paper, all of them 16,076 number. So his approach 1 would be that he purchases 16,076 number of each item. So do you think that this is a wise decision? Because this year 45,000 pens were sold, and next year he is planning to buy only 16,076 pens. So is that a wise decision? No, because he will very quickly run out of stock. Similarly, this time only 30 glitter pens were sold, and next year he is planning to buy 16,076 glitter pens. So what is going to happen? A lot of glitter pens will remain in stock. It will just remain in his shop. They will not get sold. So do you think that this is a wise decision? No. So that means in this scenario, finding the mean was not the right thing that we had to do. So then what is that thing that we will have to calculate out of this data to find out which are those items which are selling fast, which are those items which are moving fast, which are those items which are in more demand, so that we can buy those items more, and the items which are not getting sold, we do not buy those items a lot. So what would be a better approach? So let us look at, and let us in fact understand the better approach now. So the better approach is that he analyzes which items are sold more. So what does he find? He finds that there are certain items which are sold more. What are those items? In this case, those items are pencils, because pencils have the highest sale. The next sale is of the pens. The next sale is for the books. And the next sale is for the glue. So he finds that pencils, pens, books and glue, they have more, they are like fast moving items. So the shopkeeper decides not to buy glitter pens or chart paper because their sale is very less. So he decides that, okay, this time I will not buy glitter pens or chart paper at all, because anyways only 30 or 40 are being sold. So that's okay. Let me not buy them. Instead, let me buy more pencils and pens and books and glue. Right? So this approach is definitely going to be a better approach. Right? In this case, he will not have a lot of items getting accumulated in his shop without being sold. So that would not happen. Right? But the question is, how does he find those items which are being sold more? So to find that, he needs to find out that particular data from the table that corresponds to more frequency. That means that happens more often. So by looking at the data here, you can very easily say that pencils are the fastest moving items here. Right? Why? Because the number of pencils that are getting sold is huge. The number of times, when you say pencils is 50,000, that means pencils got sold 50,000 number of times. So this 50,000 basically represents the number of times pencil got sold. So it is nothing but the frequency of pencil. So mode always represents that data which corresponds to maximum frequency, or that data which gets repeated maximum number of times. So mode indicates the most frequently occurring data in a group. Right? Now you understand, right, that why do we need to find most frequently occurring data? Because in a lot of situation, like the situation of the shopkeeper, you need to know that particular data which occurs more often. So we can also say that mode also tells us the central tendency of the group of data, but in a different sense than that of median, than that of mean. For example, when we were talking about mean was like finding out an average. So it used to tell us a central tendency of the data, because that number used to lie somewhere between the smaller number and the bigger number. So that ways it used to tell us the central tendency. In this case also, mode tells us the central tendency because it basically tells about that data which is getting repeated most of the times. So basically that data is happening most of the times. When you look at this example, what do you see? Let's imagine a situation that there is a shopkeeper and the shopkeeper is selling different things, sometimes books, sometimes pens, sometimes pencil, and so on. Now, throughout a year, so the entire year, you just kept observing that shopkeeper and you found that most of the times, more than half of the times, he was selling a pencil. Right? So that pencil corresponds to the data that occurs maximum number of times. So when you look at the overall set of data, which data is more dominating? Pencil, because that happened most of the times. So that ways pencil was like the central tendency of the group of data, because pencil was happening or pencil was getting repeated most of the times. So that ways mode also represents the central tendency of a group of data, but in a different way than that of arithmetic mean. So now let us try to calculate mode. So here again, heights of 25 children are given and you will have to calculate mode. Now what is mode? That data which corresponds to the maximum frequency. So in order to calculate mode, first of all, we need to we need to organize this data in a tabular form. So how do we organize this data? So let us first arrange the data in increasing order. But this time what we will do is, so whenever we have to calculate mode, we generally do not write the repeating data over and over again. Instead, we write everything once and then we will write their frequency using tally marks. So let us say we create these columns. First column is for height, the second column is for the tally marks, and the third column is for frequency, just to see how many times each data gets repeated. So the smallest height that you have is 16, and then the next one is 160, then 161, then 162, 163, 164, 165, 168. So these are the different heights that you have, right? Now how many times each of these heights occur? So 16 occurs 160, this occurs 3 times. So you see 1, 2 and 3. So it occurs 3 times. 161 occurs once. 162 occurs 4 times. 163 occurs 9 times. So this is 5. This dot, when you scratch it, it represents 5. So this total represents 5. Then you have 6, 7, 8, 9. So 164, it gets repeated 3 times, 165 also 3 times, 168 once. So let us write the frequency. It is 131493331. So this is how we prepared the frequency distribution table. Now we have to find out the mode. So mode will correspond to that data which maximum frequency. So which is our maximum frequency? Maximum frequency is 9. And what is the data corresponding to the maximum frequency? It is 163. So therefore here mode is 163. Now what does this mean? This means that maximum children have a height of 163 centimeters. So when you look at a class which has 25 students, most of the students have a height of 163 centimeters. So in that sense, it is also a central tendency, because this is the height which is being acquired by most of the students in the class. So that ways it is a central tendency of the group of data. So this is how we calculate mode. Now, do you think that the value of mode and mean of a group of data will always be the same? No, not really. It is not necessary that the value of mode and mean will always be the same. Sometimes coincidentally the two values can be the same, but otherwise there is no such rule that they need to be same. So let us look at this set of data which represents scores of different students in a class, and let us try to find out mean as well as mode for this set of data. So let us try to calculate mean. So how do we calculate mean? Mean is the sum of the scores divided by the number of scores. So sum of the scores would be 70 plus 45 plus 70 plus 70 plus 42 plus 55 plus 61 plus 70 plus 80. So sum of the scores divided by number of scores, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this divided by 9. So the value that you get is 62.55. So this is the mean. That means the average score of the class is 62.55. If we assume that all the students have scored equal marks, then the score of each student is 62.55. So this is the meaning of mean of the student score. Now let us try to calculate mode. Now when we calculate mode, what do? We need to find out that data whose frequency is maximum. So for that we will have to prepare the frequency distribution table. So let us draw one column for score, let us draw another column for tally, and the last column for frequency. So what are the different scores? Let's arrange it in some order. That would also be better. Let's say we write 42, then 45, 55, 61, 70 and 80. These are the different scores obtained by students. So how many students scored 42? Only 1. 45, 1. 55, 1. 61, 1. 70, 4. 80, 1. So basically, so this should be written like this in tally. So this would be 1, 1, 1, 1, 4 and 1. So which is the maximum frequency? 4. And this maximum frequency is for which data? It is for 70. Therefore, the mode of this data would be 70. So what does this mean? This means that maximum number of students in the class scored 70. So you see the values of mean and mode, they are not equal. Mean is 62.55, mode is 70. But both of them in some way convey a message about the overall performance of the class. So if the class teacher of this class goes to the principal and tells that the average score of the class is 62.55. So the principal gets an idea that, okay, if I assume that everybody scored equal, then each student scored 62% marks. Now the same teacher if goes and tells the principal that the mode of the student score of class 7 is 70. That would mean that most of the students in the class, maximum number of students in the class scored 70. So both of them in some way convey a generic information about the overall performance of the class. So please understand the difference between the two, mean and mode. They are not the same thing. They are two different things, but both of them represent the central tendency of a group of data in two different ways. So now we will introduce another concept, the third important concept of median. So we learned mean, we learned mode, and now we are going to learn median. So what exactly is a median and why do we need it? Now let us think of an example. Let us say that there is a dance show that is going to happen in your school, and for that dance show the choreography is such that you need 5 students of a particular height to make the first row. You need 5 students of some different height, like 5 tall students at the last row and 5 comparatively shorter students in the first row, and you need 1 student in the middle who would be like in between, who would be like intermediate between the students at the end and the students in the front. So basically these students need to be arranged with respect to their heights. So 5 students of more heights at the end, 5 students of lesser heights at the first row, and 1 student of intermediate height should be at the center, should be in between the 2 rows. So that is how your dance show needs to be organized. So how do you do this? Let's say you have been given a data where you have a list of students with different heights. So their heights are being mentioned here, and you have to, basically what you need to do is, from these students you have to divide them into 2 groups such that one group is greater than a particular height and the other group is less than a particular height, and you also need 1 person to stand at the center who is like in between, right? So how are we going to arrange this data? So do you think that calculating mean would help? Not really, because mean will just tell you the average height of each student. So with mean you cannot divide it into 2 groups of different heights. You can't do that. Do you think mode will help? Because mode will again tell you that most of the students have which height. That is, it will tell you that height whose frequency is more, that height which occurs more often. But again with that you cannot divide it into 2 different groups of 2 different heights. So this is the place where we need median. Now how will median help? So let us see what exactly is median. So what we do is we arrange this height in an increasing order. So let's say we arrange the height in increasing order or ascending order, whatever you call it. So when you arrange this height in increasing order, you get a data like this: 118, 120, 124, 125, 128, 139, 148, 150, 153. So we'll write it here, 150, 155 and 158. So this is how we have arranged the heights in increasing order. Now once you have arranged it in increasing order, can you find that that data which is located exactly at the middle, such that if you select that data, you have equal number of data on both sides. So how many data do you have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you have total 11 data. So that means if you pick up the sixth data, you basically have 5 on this side, 5 on the other side. So 1, 2, 3, 4, 5 on this side and 5 on the other side. So basically this 139 is the middlemost data. So if you pick up this 139 to be this middle girl, then what happens? These data 118, 120, 124, 125 and 128, all of these are students of smaller height, so they can all stand in the first row, and all of these are students of greater heights than 139, so they can all stand at the last row, and this girl with 139 centimeters as height can stand in middle. So this 139 is median of this group of data. So median is nothing but the middlemost data in a group of data. So whenever you have a group of data and you want to divide that data into two different parts, maybe you want to divide it into two parts, one part of smaller height, one part of bigger height. Or let's say if you are talking about scores of students in a class, the teacher wants to divide the class into two halves, one half for the students who scored less and one half for the students who scored more. So there also he can make use of median. So median always talks about the middlemost data in a group of data. So you see in this example, the example that we considered here median helped. So mean would not have helped, mode would not have helped, but median could help. But in a way, again, when you look at median also in some way represent the central tendency of a group of data, because here you see this is location wise, it is the central most data, the middlemost data. So that way it tells you the central tendency of a group of data. So that's the beauty of statistics. You have three different concepts of mean, median and mode. All of them are very much different from each other, but all of them in their own ways, they represent the central tendency of a group of data. Fine. So now let us look at another example of finding median. So let's say that the teacher decided to divide the total number of students in a class into two sections depending on their scores. And the scores of the students in a class is as shown on the screen. So this is the score of different students in a class. Now this entire number of students, they are going to be divided into two different sets of data depending upon their scores. So those who have lower scores will be in one section, those who have higher scores would be in the other section. So how is the teacher going to divide it into two sections? So for that, the teacher needs to find the median. So all those students below median will be in section A, all those students above median will be in section B. So that's how you can divide them into two sections. So for that, what is our first step? So first, let us arrange the data in ascending order. So we get something like this: 28, 42, 45, 54, 55, 61, 66, 69, 70, 70, 71, 75, 78, 82, 83, 91 and 93. Now please remember that even if you have repeated data, for example 70 is repeated twice, so you write it twice. So just that you need to arrange it in an ascending order. So once you have arranged it in ascending order, how do you find the middlemost number? So total how many do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17, that means 17 can be divided into 8, that is 16. So the ninth data would be the middlemost data. 1, 2, 3, 4, 5, 6, 7, 8. So this is the ninth data. So this is going to be the middlemost data or the median. So the median for this group of data is going to be 70. That means all those who scored less than 70, all these students, they would go to section A. And all those students who scored above 70, that is all those who are after the median value, they are all going to go to section B. So this is how the teacher can actually divide the total number of students into two sections. Now section A would comprise of students with lower marks, so that more attention could be given to the students in this section. Whereas section B, they have higher marks, so accordingly attention can be given to these students. So that's how you have divided them into two different sections. Now what happens to this student who is actually the median, who has scored 70? So this median becomes the class leader. So he is someone who has scored like an average marks, not very less, not a lot of marks. So it's like his performance is kind of average in the class. So this person becomes the class leader, managing both the sections. So this is how you can actually divide a group of data into two different sections depending upon their values, right? So that is the significance of median. Now, have you observed something? In both these examples that we discussed, the dance show as well as the class leader, in both of these, the total number of data was odd. So here we had the total number of data was 17. So it was very easy to divide it into two equal halves like this. 8 on this side, 8 on this side, and the center one was median. So that's how you divide it. Again, in the previous example, the total number of data was 11. So again, that was easily divided. 5, 5 on both sides, and in between you have the median. Now, the question is, what would happen if instead of odd number of data, we have even number of data? Instead of 17 students in a class, if we have 16 students in a class. So how do we calculate the median? So let us try to calculate median for even number of observations. So let's say that the scores in mathematics test of 10 students is as follows. So this is a data for 10 students and we have to find out the median. So the first step would still remain the same. We just need to arrange it in ascending order. So once you arrange it in ascending order, you get something like this: 5, 9, 10, 15, 16, 19, 20, 23, 25. So 20 is repeated twice. So 20, 20, 23, 25. So this is your data arranged in ascending order. Now, will you be able to find out a middlemost number here? You can't, because you know there is no such number which will be the middlemost. So if you consider 16, so this side you have 4, but this side you have 5. So 16 is not the middlemost number. If you consider 19, this side it is 4, but this side it is 5. So 19 is also not the middlemost number. But basically, the middlemost number should lie somewhere in between these two, right? Because this side also you have 5, this side also you have 5. So this is somewhere the middlemost number should lie. So how will you calculate the middlemost number? Now middlemost number is nothing but the median. So median or the middlemost number would be the average of 16 and 19, because we believe that the middlemost number is somewhere in between these two. So how will you calculate it? Sum of these two, 16 plus 19 divided by 2. 2 because we are dealing with two numbers. So 16 plus 19 is 35 divided by 2, which is equal to 17.5. So 17.5 will be the median of this set of data. So whenever you talk about odd number of observations, the value of median is one of the existing data from that set of data. But when you talk about even number of observations like this one, the value of median is not seen in this data. It is something else outside this data. For example, 17.5 is the median in this case, but 17.5 is not one of the existing data out of this set of data, right? So therefore, only for odd number of observations, the value of median is actually one of the data in the group of data. So let us now quickly look at some of the questions based on mean, median and mode. Question number 1. The runs scored in a cricket match by 11 players is as follows. Find the mean, median and mode of this data. Are the three same? So first of all, what we do is we arrange the data in ascending order. So we arrange it in ascending order. So what do we get? We get something like this: 6, 8, 10, 10, 15, 15, 15, 50, 80, 100 and 120. So this is what we get. So total, so let us also try to arrange the same data in tabular form. So how do we arrange it in tabular form? So we have one column for the runs and we have another column for the frequency. If you want, you can have another column for tally as well. Otherwise, you can directly have frequency also. So here what we will do is, in this table, we are not going to repeat the data. Instead, we are just going to write everything just once. But we will write their frequency. How many times 6 is getting repeated? 1. 8, 1. 10, 2 times. 15, 3 times. 50 again 1. 80 again 1, 100 is also 1 and 120 is also 1. So this is how we have established the frequency distribution table. So we have arranged the data in ascending order as well as in tabular form. Now we can very easily calculate all the values. So first we calculate mean. So mean is nothing but sum of the values, that is sum of all these values divided by how many values do you have. Definitely you have 11 values because these are the runs scored by 11 players. So you will find it out like this: 6 plus 8 plus 10 plus 10 plus 15 plus 15 plus 15 plus 50 plus so on till 120 divided by 11. So the sum comes out to be 429 divided by 11. This is equal to 39. So the average or the mean of these data is 39. Next we have to find out mode. So mode represents that data with maximum frequency. So let's look at the frequency distribution table. This is the maximum frequency. Which data corresponds to maximum frequency? It is 15. Therefore mode will be 15. Next we have to find out median. Median is the middlemost data. So here when it has been arranged in ascending order, we have total 11 pairs. So we can divide it into groups of 5, 5. So 1, 2, 3, 4, 5. This 5 in one group, and again from the end 1, 2, 3, 4, 5. This 5 in the other group. So which is the middlemost data? So the middlemost data is 15. So what do we observe? We observe that in this case mode and median are the same, but they are not the same as mean. Therefore, no, all the three are not same. Question number 2. Find the mode and median of the data. 13, 16, 12, 14, 19, 12, 14, 13 and 14. So first of all, we need to arrange it in ascending order. So we get 12, 12, 13, 13, 14, 14, 14, 16 and 19. So this is how we have arranged it in the ascending order. We can also make its frequency distribution table. So let's say we have one column for the data and the other column for the frequency. So what are the numbers that we have? 12, 13, 14, 16 and 19. So if we look at their frequency, 12 is repeated twice, 13 is also repeated twice, 14 is repeated thrice, 16 once and 19 is also once. So in this case, what would be the mode? So mode corresponds to the number with maximum frequency. So maximum frequency is 3 and the number corresponding to maximum frequency is 14. And what would be the median? So median is the middlemost term. So here 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can divide it into 4 groups of 4 and 4. So the middlemost number again is 14. So in this case we see that the mean and the median and the mode of this set of data are the same. Tell whether the statement is true or false. Mode is always one of the numbers in a data. So do you think mode is always one of the numbers in a data? Mode is a number in that set of data which has maximum frequency. So definitely it has to be one of the numbers in that data. Mean can be one of the numbers in a data. Well, mean, yes, it can be, because here it says it is not necessary that mean is always one of the numbers. But yeah, in some cases it might be. So let me give you an example. So in this case, let's take the example of mean of first 5 whole numbers. You remember we calculated this some time back. So what are the first 5 whole numbers? 0, 1, 2, 3 and 4. So when you calculate their mean, what do you get? 0 plus 1 plus 2 plus 3 plus 4 divided by 5, because you are dealing with 5 numbers. So this comes out to be 10 by 5, which is equal to 2. So in this case, mean, which is 2, is also one of the numbers in the data. So therefore it is possible that sometimes mean can be one of the numbers in the data, but it is not necessary that mean will always be one of the numbers in the data. The median is always one of the numbers in a data. Well, this is false. That is because median is one of the numbers in a data only when, so this statement is true only when the total number of data is odd, only when we handle odd number of data. Because you remember, whenever we have odd number of data, in that case, let's say you have 9 data. So 4 on this side and 4 on this side. So the median is the data which is at the middle. But when you have 8 number of data, in that case your median is not one of the numbers in the data. So you actually take out the average of the 2 middle terms and then calculate the median. So in case of even number of data, median is not one of the numbers in the data. A data always has a mode. Well, this is not really true, because you cannot say always, because many a times it might happen that a set of data exists where all of them have the same frequency. So there you really do not have the concept of a particular data with maximum frequency. So therefore you cannot say that a data always has a mode. The data 6, 4, 3, 8, 9, 12, 13, 9 has mean 9. So for this we will actually have to calculate the mean of this data. This would be 6 plus 4 plus 3 plus 8 plus 9 plus 12 plus 13 plus 9 divided by 9. And when you actually calculate it, the mean comes out to be 8. So the mean is not 9, the mean is 8. So this is false.
I hope this video was useful, but as I always say, that maths is a subject which needs a lot of practice. It's not enough to just watch the video. You need to first watch the video and then need to solve some problems on your own. And if you're able to do that, you are done. So if you really like the video, do not forget to share it with your friends so that more children can enjoy learning with this video. If you have a feedback for us, do let us know in the comment section. We will be more than happy to hear from you. So I will meet you all very soon with a new video, with a new topic. Till then, stay home, stay safe, take care. Bye-bye.